exhaust valve so all the spent air can come out the exhaust, which is right here. So that's generally how it works. You can see it spins up and down, that spins the shaft. Now we'll open the crankcase. You can see inside there.
Juniors, what class is that from?
Yeah, does anyone know what class the engine stuff is from? Applied thermal, right? So it's real. It is actually real. It's not made up.
You'll get there, Mario. One day.
Not how you would do it.
Yeah, I got my
If you're going to say
Have you guys got any type of
the crankcase cover, right? This keeps the oil inside. If your machine's on, there's a couple bearings, right? The bearings make it so something can rotate without creating too much friction. The crankcase cover. And there's inside the engine. So as this is turning, you can see the crankshaft moves the piston up and down. And this is kind of an odd engine because the output shaft is not the same as the crankshaft. But when you bring it down here, so you can see it. I thought I drank it well. So you can see as it's rotating the piston up and down, it spins the shaft to put power out. And then this is out of a snowblower. So this is like a reducer to take high RPMs and bring it lower to have more torque to run the snowblower. So yeah, now I don't know if I can get the rest of this apart. I'm going to take the exhaust off. Oh, I skipped this. Applied thermal is real. I think I said that. But that's the auto cycle, is the intake compression and power switch exhaust. So that's where you're generating your power to run your car. Now, this is the exhaust. So as you can imagine, exploding stuff inside of the cylinder is pretty loud. So the exhaust comes through there to exit away from the engine, but this also muffles it. There's like, I should have cut it open, there's like baffles in there. It's a whole bunch of sheets of metal with holes in different spots. So the noise kind of bounces around in there and comes out quiet. So if you ever heard a straight pipe car or some jerk driving around, it's kind of loud. So that's that. Next on the Wesson plan is the Venturi, but I'm going to see if I can get this off. If you have any questions, you can ask me as we go.
Why is it called Mini Baja and not Baja?
It's a good question. The Mini Baja came out in I think the 80s or the 90s, and there's this Baja racing, if any of you are familiar with racing. They build like pretty large trophy trucks, and they race them across the desert. And this is going to be like a miniature version of that. But then like 5 years ago, they decided to just start calling it Baja. But our school never adapted, so it's still called Mini Baja. So, like, hopefully this piston's slacked out easily. Show the piston, and then go to the carburetor, which has some
Tristan, I'm seeing you later today.
If you have any
I'm
questions,
seeing you later today.
Yeah.
What am I tuning you in?
Statics.
Statics, gotcha.
You cool with that one?
Yes, that's good. I got it.
Yeah, I got a quiz tomorrow.
Who you with? Cipollone, Sabori?
Sabori.
So there's the actual piston. This is what's traveling up and down. You can see there's like carbon deposits on the top. That's usually not good. It means like the engine was running rich, a little too much fuel. And then on the side of the piston, you can see these are called piston rings. This keeps it so there's like a seal between the cylinder walls and the engine. And like when it explodes, it actually pushes down and the power doesn't go right through the sides. So that's the piston. I'm just going to leave this on. So that's the engine. Oh wait, hold on, I forgot the part. I think on your page 3, there's going to be a carburetor going over how the carburetor works. Hold down and I'll show you guys.
Who said that? Who said that?
What?
Who said that?
I can hear you.
Who here is taking fluids? Is anyone taking fluids? They're currently taking. Alright, this is good then. On page 3 of the lesson plan, you can see this is called the venturi. So there's a cross section that constricts down, so it gets smaller, and then it gets bigger again. That's called the venturi. That's how a carburetor works. So what is a carburetor? It delivers fuel to the engine to run. But how it works is pretty interesting. It works by the fluid properties that Bernoulli's equation, as the air is flowing through here, when the area gets less, the velocity increases but the pressure decreases to satisfy Bernoulli's equation. And when the pressure decreases in the center, there's a straw coming up, and that low pressure sucks fuel up the straw to deliver it to the engine. I'm going to see if I can pull this apart. Every size is different. So Bernoulli's equation is also real, as we can see.
Come on.
Alright. We don't need that part. So the carburetor, usually older cars only use carburetors in smaller engines. But you can see the venturi. In the center of that venturi, at the point where there's the lowest pressure, this like straw is going up. So at that point of low pressure, it's sucking the fuel out of this bowl. And this bowl holds the fuel so it can get delivered. And I think this is pretty ingenious, whoever thought of this. But there's a float in here with a little pin, and the fuel comes in from the gas tank there. So when it's full of fuel, the float ball is floating, preventing gas from coming in. But when it's running out of gas, it goes down, lets more gas in. And then it's all just Bernoulli's principles, pulling fuel in. So none of your cars probably have a carburetor, but your lawnmower or your snowboard does, or if you have a really old car. So it's pretty interesting. Anybody got any questions up until this point?
So there's isn't there also like a high speed and low speed needle for tuning as well?
Adjustment, yeah. So this is like, I simplified the part, but if you look at the picture, I cut one in half for Dr. Busa a long time ago, and I forgot to bring it. But you can see there's all little passageways, and besides it just being a venturi, all those passageways allow different amounts of air and fuel to get like the right mixture. And when you adjust those pins, it adjusts how much air and fuel is going through that. And there's also the valves, which control either the choke, which makes it so less air and more fuel goes in to start it cold, and then the throttle, which when you give it throttle, as you can imagine, more air and fuel come in to run the engine.
Yeah.
So, any other questions on up until this point? That's a carburetor. I think that's the wrap of the engine.
That's it.
Yeah, that's the wrap of the engine.
I
Anyone got
have
any
one of those
questions
in my
on
next
the engine?
car, and
I
it's
kind of went fast.
to change
The doctor out of mine told me the transmission was.
I feel like usually we
But I
don't have
figured you might as well
problems.
know how the power
Huh?
gets into
In our engine, we don't really have problems with our car.
all the stuff's real, all the stuff you learn from the fluid principle. That's how this works when you do fluids
To
lab.
start it, sometimes you have to back off.
Thermal fluids lab, you're going to do actually an experiment on this where you see how it really works, and you'll be able to say, hey, wait a minute,
Just
that's how my
stop
one
the
works.
and then once I
So,
start it, then I have to.
that's the basics of an engine. Next, we're going to talk about this Nissan CVT transmission. So, I put a picture here. In a car, the powertrain or the drivetrain is a combination of all the parts that put the engine's rotational speed to the wheels. So the engine part of the powertrain, transmission, axles, etc. We went over the engine. Now we're going to look at how the power from the engine gets to the wheels. So, the first step is this pretty cool thing that I don't know how someone figured this out, but they made it's called a torque converter. So we're looking at an automatic transmission. The power from the engine goes into this. This is the torque converter. It's usually a sealed unit, but I popped it open for you guys because I think this is pretty cool. It's like a turbine pump. It's a turbine pump. So the engine's spinning this side here, and then this goes into the transmission. And this is full of fluid. And when it's spinning at low speeds, there's not much torque on the fluid, so the fluid's trying to go around. But if you've ever been driving your car and you're on the brake, you don't move. But as soon as you let off the brake, since there's no resistance, it starts to move. And as you give it more gas, the housing, let me see if I can pull this apart. There's a lot of parts. The housing starts to spin, which pumps more fluid across the other side and starts to drive the car. So, let me see. So this is the torque converter. It's basically like a turbine or a pump, if you're familiar with thermodynamics or fluid dynamics. And that's how automatic transmissions work, as opposed to a manual car where you have a mechanical clutch. So, I think this is pretty cool, because I don't know who figured out how to make this thing, or how they made it. Because it's a pretty complex part. You can see all the turbine fins there, all lined up. I think this is called the stator. Yeah, the stator's like the magical part, which pushes the fluid to make sure it goes on both sides. And you can see these fins are fixed. So this is fixed to the side that spins in the engine, and fixed to the side that goes into the transmission, and this is free. So the whole thing is always rotating, but the part going into the transmission only rotates once you put enough RPMs in to pump the fluid across to the other side. There's probably a lot of confusing words. Does anybody have any questions about the turbine? How you got to open the torque converter? No? It's pretty cool, right? Yeah, what's up, Yeah. So this would have been full of fluid. So this would have been completely full of transmission fluid. I had to drain it to show you guys. But when this is completely full of transmission fluid, the whole thing's rotating, but the part that's connected to the transmission, transmission and the wheels is only this. So when the whole thing is rotating and you're on the brakes and there's not a lot of RPMs, this stays still and the rest is rotating. Once you start to give it gas, it's pumping the fluid into here and making this rotate also. So it starts turning. That's why when you're at a red light, you're on the brake with your automatic car. When you let off, you start to roll, because since there's no more resistance, it's able to pump the fluid. And as you give it more gas, it's pumping more fluid. It's a lot harder to hit the brakes. That's how people do. So, any other questions about the torque converter turbines? So, we leave this right here. Pop this off. Leave this right here. Pretty cool. It uses all the fluid principles, and when you take manufacturing, it's pretty impressive how someone had to figure out how to make this thing. It's pretty interesting. So that's the torque converter. From the torque converter, it goes into the actual transmission, which is here in the input shafts. And the power's going in here. Magical stuff happens. The power comes out of your axles like this. So we're going to take off this side first and show you what it looks like going in. is why mechanics hate engineers. Sometimes you can't reach the bolt of the impact. You have to do it correctly. Start running up. Is the transmission. So you saw from the torque converter, the power goes into here, and then it's going to go into something on the other side on the CVT. But you can see, pretty complicated. On this side, this chain goes down to a thing down here. It's a pump, pumping the fluid that's down in here into all the components. So I'm just going to pull some of these things out because we're going to go over them in a minute. I had to take this side over first to get to the other side. And now we're going to go see where this shaft goes to the other side. If you have any questions, you can let me know.
Is it up to the side door?
Huh?
What's that up to the side door?
What color?
Like on the floor over there, what is that?
The blue thing?
Those metal parts that are on the cardboard.
Those are, oh, that was in the CVT. So that was the set of gears he took out. Those are gear sets. But they're on a shaft right now. He'll show them later. But when you get into machine design, right, you're gonna have like your gears and bearings. So like that's all it is. It's just a shaft. But they're loaded with stuff on it. I've never seen it inside, but
That's basically what I got up to when I disassembled my boat motors.
Yeah.
I just dropped the lower unit.
yeah.
You see your model first go.
Ooh, Joe, what year does this come from?
Good question, Christian didn't tell me. I think this is between 2007 and 2014. Because that's when Nissan had transmission problems. If you remember. Got it. Alright. Don't do this, Steve. It's your fault. This is not going back together. Alright.
Joe, what is that red?
That's, okay, so the red stuff, RTV, is sealant. It's because there's fluid in here. Keeps the fluid inside. Wow.
I didn't remember that.
transmission. It's called a CVT. It's called a CVT. So what is a CVT? It's called a continuously variable transmission. It uses two pulleys that can change in diameter. So if you're familiar with gear ratios, you have two different pulleys, two different sizes. It changes the ratio. The thing about a CVT is, in theory, they're very, very good because there's an infinite number of ratios between the minimum and the maximum, because these pulleys can change infinite many times between the min and max. So there's two pulleys. There's the driver and there's the driven. The driver pulley is the pulley that's getting the power in, and the driven pulley is pushing the power back out. And connecting them is this belt. Which one's the driver? So this is the driver pulley. So the power came from the engine through the torque converter into this pulley. At low RPMs, this pulley is completely open. I put a nice little diagram so you can see. At low RPM, the driver pulley completely open, and the driven pulley completely closed. So it's as big as it is.
Yeah. Thanks for coming, Tristan.
As you're
I'll see
giving
you
it
later.
power, the driver pulley is coming in, making its diameter bigger, and the driven pulley is going out, making its diameter smaller. And if you do the math of the gear ratio, the driver over the driven, I think, the gear ratio starts to go down, which means for every one rotation in, you're getting, let's say, one rotation out, as opposed to at low gear, one rotation in, you're getting like a third of a rotation out. So you're trading speed for torque as you're giving it more gas. So that's the basic concept for how this thing works. I don't know if it's going to just come out easily. I have to hit it. So the power goes in here, transfers over to this pulley, and comes out. Anyone got any questions on it? Makes sense, right? If you're doing your machine design project, the CVT is the first part of the project. I gave you guys the ratio, but you have to know the ratio going into to get your final gear ratio. So that's the CVT pulleys. I don't think I can easily pop these off, but hopefully I took apart another transmission. So again, this is a driver pulley. As the RPMs pick up, there's a pump inside the transmission pumping fluid, and through a whole bunch of electrical passages that open and close valves, the fluid goes into the CVT, pushing this to this side to make it go bigger. The driven pulley starts off as a bigger diameter, but as fluid is pumped into this, it opens up to become smaller so your car can pick up speed. So think about it. Slam on the gas as you're taking off. This pulley is getting bigger and the driver pulley is getting smaller, so you get a better gear ratio. And then, machine design or not machine design, everything that rotates has a bearing on it. Because if you don't have a bearing on it, it's just spinning in the housing, generating friction. Friction's not good inside the gear case. So there's a regular ball bearing, pretty big one, on the CVT. I don't think I could take this apart much further, but the CVT uses a belt between the two parts. Is there a belt? Oh, there's one. Thank you. The CVT uses the belts between the two pulleys. In cars, they're made of metal. If you do Baja, it's made of rubber. But the belt is what's connecting the two pulleys. So I chopped this one in half this morning so you can see it, because I didn't think I could get this out. So now the power went from the engine through the torque converter into the CVT. It's coming out of the CVT. Does anyone know what kind of gear this is? What? Exactly. It's a helical gear. So helical gears, they're a little better than spur gears because there's more contact area between the gears since they're on an angle instead of straight. Now, so the power comes out of here. Now, pressed into the case, you can see the cup. The cup is for tapered bearing. Couldn't remember. I passed machines. This is a tapered bearing. So tapered bearings, as opposed to the ball bearing that you saw over there, is for a load that has thrust on it. So since this load, helical gears generate like a thrust, it pushes this bearing into this cup. Wow, that's not the it's on this one. It pushes it into the cup to rotate, so this can rotate without generating too much friction. And you can see all the bearings that have helical gears on them have a cup in there and use tapered bearings. I did not like tapered bearings. Don't do helical gears. So yeah, and then you can see there's a gear train. So instead of just having the power all of a sudden come out, you might want to gear it down. So when engineers design it, they have like a set of goals for the car and an environment that they have in mind. Like a truck is geared differently than your car. And based on their goals in mind, they choose different size gear ratios to gear up or down the car. So, the power came out of the CVT, now goes into this. Where's my lesson plan? I gotta make sure I touch everything. Oh, I missed something. We're gonna take this apart in 1 second. We're gonna get to the end and then we're gonna backtrack. So, power came in through the torque converter into the CVT. It went through this unit, which we're going to talk about in a minute because I skipped it. And then it came through these helical gears with the tapered bearings, and it goes into a differential. Differentials are interesting. So, if you think about your car on the road from above, when it makes a turn, the radius of the turn, the inside wheel has a smaller radius than the outside wheel. Everyone understand what I'm talking about? You make the turn. So that means the inside wheel has to make more revolutions than the outside wheel. So if you just had the axles directly connected to the gears coming out, the inside wheel would have to skip in order to account for the outside wheel. So some very smart guy figured out this thing called a differential. What a differential uses is bevel gears. So the power is driven into this big helical gear, which drives the whole thing. But inside the whole thing, there's bevel gears. This is the differential. So the axles come out of this, and as you're driving, these can spin at different speeds because of the differential. It's probably hard to visualize, right? So I'm trying to think how to explain this. As it's spinning, one wheel can slip completely. So this can slip. This side doesn't have to move at all for this side to keep spinning. So that's how they can spin at different speeds, the differential. Anyone have any questions? Yes. Yeah, so you know, this is a 4-wheel drive car. So the axles are coming out like right here, out of this differential. And your inside wheel then doesn't have to spin at the same speed as your outside. If you've ever gone like off-road or seen like an off-road video of an unlocked differential, which is this, which is what all cars use, when you get stuck in the mud, the wheel with less traction is the one that does all the spinning. Because the power's not going to go through the one that can slip. That's what the whole purpose of this is. So one wheel can slip. But off-road, once you start slipping, one wheel's going to spin, the other wheel's going to do nothing. So that's how a differential works. Does that answer your question? Okay, good. Oh, we're not skipping anything. Everyone understand that? Alright, now we're going to try to take apart this thing and explain that, and then I think that's the whole spiel. A lot of gears.
Can I take one?
You want one? Yeah. You can have it. If anyone wants a gear, actually wait, I need a couple gears. I want to make some. You can then win the gear.
Sure. I'll have it on the weekends.
You have to taste it.
where the power came in through. This chain is turning a pump because there's a lot of fluid on the transmission run on fluid. This pumps the fluid through. Now I'm like this chain. Behind this is something called planetary gears, which I find also pretty interesting. Look at those. I guess look at the case one more time, and if you have any questions, you let me know. And if you want to take something home, I guess you can take something home. Thank you. I need a couple of these things for something I make. So.
Straps.
That's why connection. It's an angle grinder. I'm supposed to be explaining the tools as I go. I think I touched on it before. Yes. I'm just gonna cut this chain. There we go. Angle grinder. So, got that out of the way. This is one hand. One bolt is engineered. See, this is why, again, mechanics and engineers, they have a problem. Because for some reason, they put the bolt behind the gear. So I'm not really sure you can see. Safety is very important. That's
Safety is number one priority.
Yeah, I was thinking about a great person accurate. Took the crazy one.
If it doesn't come out now, I think that was Alright. So, if you remember before, the power came into the torque converter, but before it got to the CVT, it went through this contraption. This contraption is planetary gears and like a clutch mechanism. So, on this end, there's a shifter. You can see up here, it shifts what gear you go in. Depending on what gear you go in, it sends, now mechatronics is going to get involved in this whole thing, right? It sends an electrical signal in this system here. See, yeah, no, mechatronics wasn't fun. That was amazing. You guys have Dr. job, right?
Yeah.
She's pretty good.
Fire.
Yeah. So it sends an electronic signal through here to open and close different valves, right? Depending on which valves are open and closed, the fluid can go to different spots. The fluid can go into this system, which then puts pressure, you can see, they put pressure on these springs, which pushes the clutch pads in and out. So, in an effort to not have to cut any. So this is this. In here, it puts puts pressure on all these clutch discs to engage like different gears in the transmission. So these are the clutch discs. It's like a mu value friction. That's how that works. So then after going through that, it goes through this. I don't know if Dr. Armandi ever talked about planetary gears with you guys. Planetary gears are, no, okay. Dr. Armandi talks, planetary gears are gears that go into one kind of transmission. Let's see if I can show this. I can. So there's a sun gear, and inside the sun gear there's a whole bunch, I think they're called moon gears, that rotate. Where's the planetary gears? Thank goodness I took it apart, because this one's not going to party. Planetary gears is, there's a big gear, it's called the sun gear, and then there's little gears inside. And when this whole system's together, that's what controls your forwards and reverse. Depending on which one is turning, it's forwards or reverse. Because when they're not synchronized, let me get this back together. When they're not synchronized, one turns one way, which turns the main gear the other way. When they're synchronized, they all turn together. So that's how planetary gears work. I was supposed to find this pretty interesting. Pretty complex little gears in there. There's a lot of power going through. So you can see it comes in here, and then if this is on, alright, anyway, if this was turning like this, if you can imagine, it would rotate this the opposite way. It would rotate this the opposite way, but when they're synchronized, the whole thing rotates together. So that's planetary gears and the clutches. I'm not going to take that much. Alright, I think there's not much left left. Alright. Now the last part is this component. It's a lot of bolts on this. So the last part, when I said mechatronics and fluids that are kind of together here, is this like shifting mechanism. Depending on what the ECU, which is the electronic control module or electronic control unit of the car, is saying, because everyone's computerized now, at what speed it opens and closes different valves, or what gear you're in, opens and closes different valves. Inside of here, to have the car go to different gears, like forward and reverse, to engage and disengage the CVTs. Now this is a this is the filter. This is the filter. So there would be a cover here, the pan cover. It'd be full of automatic transmission fluid, and the pump, which is right here. This is the pump right here. Would be sucking the fluid through this filter to pump through the whole car. So it's the pickup too. I'll try to get this off to show you guys how complicated this actually is. And if you have any questions, we can go over. here is it moves a plunger inside there. And get this off now. It's making a mess here. There's always one more bolt. I find this extremely impressive. Look at how many channels for the fluid there are. So, depending on what the ECU is saying and what gear you're in, the fluid can travel through different channels here to shift the gears. I don't know who figures this stuff out. Apparently mechanical engineers, but pretty complex work in there. You know, there's a lot of channels for the fluid to go through. I find this pretty interesting. I think I can get one more bolt out. There we go. So yeah, these are shift solenoids. So depending on what the ECU is saying and what gear you're in, it opens and closes different valves to have the fluid travel through a different passageway to make the transmission do a different thing. Pretty impressive. Imagine trying to figure out how to design this and then how to make it. I think that's it. I mean, I don't think the pump comes out easily. I have to cut it out. I don't think it's going to come out. So that's bottom shift thing, this complicated part. The shift solenoids. This is the housing, as I said before, with the clutches in it and everything.
Take a look at fluid.
Yeah, there's fluid everywhere.
We're back.
And that's it. I had something at the end that I had to say. Oh, I remember now. So as you can see, a lot actually goes into designing a car. It's not just machine design, it's fluid properties, it's mechatronics. There's heat transfer. I didn't even get into the heat transfer angle. Automatic transmissions run really hot. The transmission fluid is actually pumped out of the transmission into a radiator with fins. I'm going to give you guys a little thing you can tell Dr. Wakui about when you have them. Through fins to help with the heat being dissipated from the engine, from the transmission. So that's fins on an engine, but there's also, have you ever seen a car radiator or an AC radiator? So every single mechanical engineering class goes into building a car. We just took apart one component. Wow, I got a little in there. We only took apart one component, but you can see like a lot of design work goes into it. It's pretty impressive. What else did I say? Yes, there's a lot of complex stuff that goes into it. The engineers that sit down and design different cars, I mean, that Jeep is designed completely different from a pickup truck because they have different high speeds they want to get. There's different torque they want to get. So manual, automatic, CVT, hydraulic. So I think that's it. That's everything. So if you have any questions, I can try to answer them. I hope you guys liked our teardown. I hope it was worth coming to. It was worth coming to. We made an absolute mess that I'm gonna have to clean up.
Tell us about the machine design project.
Okay. Did he assign that yet?
No.
Okay. This is what you're gonna have to do. This is inside news, okay? Because I made it. So you're gonna design a transfer case to take power at a gear ratio that's specified from an engine. I gave you the torque chart to the wheels, pretty much. So a CVT is actually a part of the transfer case product. You don't design it. I just gave you guys the CVT ratio, but you're designing a gear reducer for the Mini Baja car. So you're going to design the gears, the shaft, and the housing to be able to transmit power from the engine, which is a Kohler engine, out so that the Mini Baja car isn't going 3,600 rotations per minute, the wheels. So it's a hard project, but it's not like if you start it, when you get it, you'll be fine because you're going to design probably the gears first within the sizing I gave you. Then you're going to design the shafts. Then you're going to design the bearings and the housing. I'm going to have two like open houses here to try to like tell you guys what the best route to go as well.
Like, it's
What?
Pick it up. It's not
Oh, CVT. I have the CVT off the engine. Yeah.
no. So like,
Well, all right, but you guys are probably gonna design the gears first, then the shafts, then the bearings, then the housing. It's like a hard project, but if you don't start it last minute, you'll be fine. If you try to start it right before finals week, you're gonna have to try to figure out the whole thing really fast. But it's very doable. My whole class did it, so you guys will be all right. I'll have 2 like open houses where you guys can come and go over what I did for it that made it easier, and then you can start. And then I'll try to have like at least once a week where you guys can come by and like ask questions. And I have like 3 or 4 gearboxes that are very, very close to what you're designing that you can open up if you want to get some ideas or take some pictures of it or something. So very doable project. It's a little hard, but I think I'm going to come to all your guys' machine design class because I have another transmission that I gave Dr. Armandi. It's a geared transmission, so it actually just uses spur gears the whole way. And we'll go over like how that one works real quick. And then when the project going, you guys can come by here. I'll send out emails and I'll try to help you guys. I can't do it for you. I can't give you the ratios, but I can like coach you in the right direction. You know what I mean? So if anyone else has questions, I'm trying to hide this from you guys. If anyone else has questions, you can ask me. You can keep your lesson plans. If you didn't get a lesson plan, I'll try to send out an email to the whole machine design class. If you're not a junior and not in machine design, I guess you could write down your email and I can send you the video that I watched before talking about the CVT. I can send you a video on how the engine works and a video on how a carburetor works, which is the Venturi. So it'll cover 3 major parts of mechanical engineering. So anyone got any other questions, concerns? It doesn't have to be about this now if you want to ask about the car or whatever. So was this worth it? Okay, I don't like how when you're in class, professors just talk about stuff and they talk about stuff, but you don't get to see it. I like physically seeing like what we're trying to get, what the end goal is here. Because when like Dr. Armandi or not no specific professor, when they draw something on the board like a refrigeration cycle or a bearing or a gearbox, I don't think it clicks as well unless you see it like physically and you understand like how complex these things actually are. You know, like this like blows my mind that someone figured out. I don't even know where all these go. All these different punchers change different things. So I think mechanical engineering is pretty impressive. This is what got me into it. So anyone got any questions, concerns? I know you really want to take a gear home.
Oh yeah, I do.
Yeah. Don't worry. I don't know if I'm gonna have time for this, but I don't know if you ever seen like gearhead trophies. People take like gears and mechanical parts and they like weld them together into like a trophy. I was gonna do that, but I don't have any events planned that would be like a competition. So if you have like an event that's gonna be a competition, maybe we can give you guys some heavy mechanical trophies. Obviously, I'll clean the oil off of them. So the piston, I was actually gonna make that a part of the trophy. But if you write down your email and I can't make it part of the trophy, you can have it. How about that? I'll email you, come pick it up. So, this one? I'm not sure. So I knew someone was gonna ask this. So Nissan had a problem with their CVT transmissions. I think it was from 2007 or 8 until like 2014, where they were putting CVT transmissions and everything. But I think the belts were failing or something was failing on the transmission. Where like all these cars, it was like a big class action lawsuit. All these cars had failed transmissions with like 100,000 miles. And so people like your CVT transmission, they don't think it's good. Like Honda Civics are using them. I think SUVs are starting to use them. It's our main power transmission from the engine to the transaxle on our Baja car because like mathematically and like theoretically, it's the most efficient way to transfer power. You could be hammered on the gas the entire time and the CVT will adjust as you're picking up speed to give you more and more ratio, or it'll adjust to give you more and more torque. Like I said, there's an infinite amount of ratios between the max and the min because the pulleys can change size to whatever size the engine's rotating at. So whoever thought of it is a pretty good idea. So, any other questions? Sorry, I don't know if I answered the question, but if you look up why Nissan CVT transmission failed, someone that knows a lot more than me will be able to answer it. I don't know a lot about automatic transmissions. I was trying to get a manual transmission because that's all gears, all synchros, but it's a lot harder to find a failed manual transmission than a failed automatic transmission because manual transmissions are all mechanical. There's a clutch, power goes from gear to gear to gear. So the only way you have a failed one is the gear chips. And usually gears don't fail. So when you design your transfer case, the gears shouldn't fail. So yeah, any other questions? you really want to take something, I mean you can, but they're all oily. And the gears, I need some of them to make
I'm
something.
greasy.
What? you want the case. You can probably scrap it. I think that's what I'm gonna do after this. So I had another transmission torn down over there, but I couldn't get it the whole way. So some of the parts here are actually from that Acura transmission, and the rest is from the Nissan. And then there's a small little Honda engine. I figured you guys might like seeing where the power starts instead of just going straight into the transmission. But yeah, this is crazy. Imagine manufacturing that thing. Or even manufacturing these turbine blades. I mean, look at how like complex it is. It's not one piece. You can see the blades are like clipped into the housing and bent over here. So, and they make every automatic car has one. So they're just pumping these things out. But some mechanical engineer, one had to figure out how it worked, and then two had to figure out how to make it efficiently. So, yeah, what's up?
So, like, for this transmission that's in the Baja car,
Yeah.
like, can you give like an example of like a problem you've had with it before?
That's
if you
all right.
have?
Yeah, so I went to the Maryland competition with the team. We had a lot of problems. But one of the problems was a couple of years ago, 2 years ago, I think. They, instead of just having a transfer case, they have it going into a like 2-speed manual transmission out of I don't know what. I think it's made for race cars, and then going into a chain-driven transfer case, not a gear-driven transfer case. But the manual transmission, like the gear selector broke. So in Maryland, we were just kind of kicking it into forwards and high gear and low gear the whole time. So the transfer case didn't fail, but the shifters did. I think on the transmission that they made from scratch, which I'll show you guys when you come here for the machine design project, or after this, you want to see it now because you're not a junior. I think the shaft failed, so I don't know if they did the whole math. They had like a 1-inch shaft, and then all of a sudden there's a really big step down to 3/4 of an inch. And if you're familiar with machine design, that's a stress concentration because you just have a shoulder, and that shoulder was really big, and I think it sheared off. So the shaft just broke in half, and then there's no more power to the front wheels. So that's why design is very important. You actually have to do all the things. All those failures, I remember when I was in machine design, I was like, I don't know how the frick a shaft ever fails. Like, it's just gonna magically explode after so many revolutions. But like, it does break, stuff breaks. So that's why you gotta be good with your design and follow the Shigley book you guys are using. The Shigley design book. So stress concentrations are real. You know, you can even see on like this little step here, they have a radius, so they filleted it. So that decreases the stress concentration, right? If you remember from solids, the stress can like more evenly move through the part. So everything's real. Everything you're learning is actually real. This is the proof. So any other questions, concerns? If you want us to tear down something else in the future, I'm open to it. I think Ashtray wants to take apart an AC unit. I'm working on getting one, because then you can see like more of the thermal fluids end of stuff. But a gearbox? Well, when you guys come here, I'm going to send an email where we're going to do that. I'm going to go over real quick how to not mess up on the machine design project.
Do you need like a wall AC unit or like a central air?
I'm going to get like a wall one probably. Why, you got one?
Yeah, I do.
All right, text me or text him, and we'll leave in the shop. Is the Freon still in it?
Probably.
Okay, then we got to take care of that because it's not good for the environment. We have to get it removed. But yeah, any other questions, concerns, other events you want to see us do? Because we're like slammed with design right now. We're building a whole new